1% packet loss. It's not enough to take you down, but it's enough to ruin your day. Slack had this problem. AWS had one flaky AZ, and it was clear that users were having a bad time. But draining an AZ meant removing a third of the site's capacity. Didn't feel right. So they waited. Sure enough, Amazon fixed the problem. Then it happened again 4 hours later. That's when Bethea decided, we can't do this. In this episode, Cooper shares how he led Slack's move to a cellular architecture, turning draining an AZ from high-risk theory into a weekly activity. Cool. So on today's episode of Turn Stories, I've got Bethea, and he's going to tell us about his experience migrating Slack to a cellular architecture. He was a senior staff engineer on the traffic and service discovery team there. Super happy to have you on the show.
Thanks, DR. I actually, my last name is Bethea.
Bethea.
And they're...
I'm
only mentioning this because I know my parents will talk or will watch the podcast. And they'll be like, he didn't even get your name right, son.
It's, one of the things I'm learning is that I almost never say the last names out loud of people that I've met. So,
yeah, why would you?
Why would I? Bethea.
Yes.
Apologies.
It took me a long time to learn your name was Thomas Rasputin.
It's something like that. So this is the topic we're going to cover today is something that you've actually talked about a bunch. You've given a talk on this at QCon. I want to start a little bit before maybe the actual story of, transitioning Slack away from the architecture of your dreams. What did Slack look like when you showed up? And what were the major fires?
My recollection, so I landed at Slack about 2019, I think about like April 2019. And I think some of the major fires that we would get wrapped up in at first, I remember there was a lot, particularly around the console installations, right? Like we were using console as our sort of back end for service registry and registration and discovery. We would have like often load or failure induced issues with these console clusters that would just render them useless, both for publishing and reading service discovery information. And that was a really big focus of ours for a while. Then we went through a lot of rounds of doing things like just making the console clusters bigger and trying to like defend them in various ways. It was a big focus for probably about the first year.
What sort of lessons did you take away from that? Was there anything, sort of leading into the Cellular Slack project? Were there pieces of the system that, dark skeletons are in the corner that you'd figured out, or was it truly separate work?
There was a lot actually that went on to inform a lot of the work that we did in Cellular Slack. I remember one of the early wins that we got was around. So we came to realize that a lot of the instability in console was driven by scaling up and down of our app servers, right? Like our what we would call web apps at Slack, which are just kind of stateless HTTP servers that do like most of the business logic. And so those would, as they needed to discover services from console, they would add load to console directly in the form of these watches. This was difficult because you have to maintain availability of the console cluster the whole time. And you kind of have to, like with a console cluster, the size of a console cluster is 5. It's a consensus driven system. It offers strong consistency. And so we kept just kind of like vertically scaling the nodes in the console cluster, but it was messy and we were running out of nodes and we still weren't really happy with the stability picture. So we ended up sort of bridging it over to this XDS control plane, which is part of the Envoy ecosystem. So we published a read-only copy of the console data into that system, which was eventually consistent as opposed to strongly consistent. And that gave us a much freer hand to kind of like scale that read service out by separating it from the write surface of console.
Yeah, that makes sense. That's it's definitely it's a challenging thing to scale. And I know Slack was not the only people to have struggled with scaling console vertically and sort of adding that capacity in a system where you can't necessarily, where you've got it attached to your monolith or whatever.
Yeah, it's tough because console is really set up to have two jobs that don't necessarily go together, right? Like you can either use it as a service registration and discovery interface where you're kind of just like pushing data into it about like what servers are available and what things are, but then also you can use it as like a log server, which is where a lot of their needs around consensus and strong consistency come in. There's actually the problem of service registration and discovery is much simpler if you relax those consistency guarantees.
Yeah, absolutely. And that was the pickup you saw with the read-only layer, right?
Mm-hmm. Yeah, with the read-only layer, we can just scale that layer separately.
Cool. So with that at the core of things, tell me a little bit about what you saw that led into Cellular Slack and that effort.
Mm-hmm. So we had always had this idea. We'd at Slack, we had talked for a long time about, well, we should be able to drain an availability zone. It was something that like we thought that we could do. AWS advertises these availability zones have, I think about like 3 nines availability, something like that. So there was always this idea that like maybe one day an availability zone will drain entirely, or sorry, will vanish entirely, and we'll kind of have to drain the site away from it. Mm-hmm. There are even kind of like some nods set up to that. There's like sort of a virtuous thing in AWS where like cross AZ data transfer is actually like a big creeper on people's cost sheets. So we had already set up a lot of the infrastructure to kind of like tunnel through the individual AZs to some extent, mostly to save on costs. But then we actually kind of went through a few outages where we were in a place, we saw a failure and we were fairly certain that failure was confined to a single availability zone, but we were really unwilling to actually start trying to administratively remove traffic from that availability zone. Mostly we'd kind of like sit around and be like, ooh, is it really bad enough that we need to do this? Because we weren't in the practice of removing traffic from the availability zone. And even if the availability zone is kind of impacted, we are talking then about like removing 33% of the overall capacity of the site, and which was intimidating if you haven't done it before. Absolutely.
How was that the sole motivation, or it sounds like there was some nervousness around it? I think Slack had a pretty good handle on its capacity in a bunch of ways, but still, like where do you think that nervousness was coming from?
I think it was from sort of a few well, there was like a sense of nervousness combined with some futility. So right, like as I mentioned, we had things kind of like tunneled into the app servers, but then there's this like large fan out of connections that the app servers actually need to make to do their work, including into systems like Vitess, which are also strongly consistent and aren't kind of trivial to just replicate across availability zones. So at least part of it was like, well, we don't even really know what this would do, right? Like we can pull stuff out of the app servers, but then the app servers and the other two availability zones will just be kind of like spreading traffic everywhere anyway. And then we know that for the most part, the sort of scaling of the site is driven by the CPU consumption of the app servers. And so as mentioned before, we're still talking about like removing 33%. So it was some piece of this kind of like theoretical worrying, and also we weren't necessarily in a place where you could kind of like get a bite at the problem. Like we didn't have a good idea of how we might start figuring out how safe it really was.
Yeah. So it's almost like the movement of, or the removing of an AZ is not something that had a really clear button, even that you sort of mentioned moving just the traffic away from the app servers. And yeah, that's a lot of Slack, but that's not the whole site.
Yeah. Yeah, exactly. I think the best we could have done if we wanted to sort of dry run it is effectively like get people from many teams into a channel somewhere and kind of like run a long experiment where we tried to drain things. And yeah, I think we never, I think we never felt that it was worth all the kind of like effort and coordination without sort of a plan of what to do about it.
Mm-hmm. Yeah, absolutely. And certainly if your default plan to do this is to get a bunch of people in a room and have them do something they haven't done before, I can imagine that the last time people want to do that is when the site's at 5% error rate and you're not sure if it's getting better or worse.
Yeah. Like if you haven't done something before, you don't want to do it for the first time in an incident ever.
Sometimes you have to, but no one likes that.
Yeah. It's undesirable.
That makes sense. That totally makes sense. So, okay. The site, draining the site or draining an AZ is not something that feels useful or even plausible in most cases, but we were having these incidents. Was there a particular incident that was the trigger to start doing work on this, or a particular insight that pushed you over the edge to actually start the project?
Yeah, I think the main one that I recollect was there was one incident where we had a graph. We had a graph of TCP retransmits by availability zone, and it was pretty obvious from like kind of the shape of the drop of the graph that we had trouble connecting from to the availability zones into like just one. Mm-hmm. And it was like it was actually quite clear from the monitoring there that there was like something going on at a network level, like in the sort of interfaces. I think it was one of the Amazon components that we believed, and then eventually found out it was going through the transit gateway that was kind of fronting the whole availability zone. So we were in the situation where it was like pretty clear cut. As much as like if we could ever have wanted to drain, we would have wanted to do it at that point. And then we were kind of like, oh, should we start trying to do this? Also, our network availability, or like we were a little bit worried about sort of being able to get into this availability zone. Our procedure at the time would have involved like SSHing around to a bunch of different servers and just kind of like causing the load balancers to health check down. I think we were kind of like talking about it, worrying about it / plotting to do it, and then the availability zone came back. The component got fixed, and we were like, "Yay! Okay, well, we didn't have to do that." Yeah, but then 4 hours later, the broken component accidentally got put back in again, and we were like, "Oh, like." Once again we were faced with a difficult choice. Like it felt bad. There was like a certain level of frustration at having been put in this situation that felt kind of powerless twice, I think, the same day. That was a big psychological motivation.
What did that show up to Slack's users as? Like, did this actually cause downtime or other issues?
So I can't remember what the SLA calculation status ended up being. It was a thing where, we have a lot of retries and stuff embedded in the site, and we were maybe, I don't know, like we were certainly not fully down. We were serving, like 1 to, let's say like an integer percentage of error rates, maybe like 1%-ish error rate, something like that. So people are having a pretty annoying time using Slack, but the service wasn't sort of hard down, which I think, if we were in that bad a state, I think we would have been much more aggressive about trying to do stuff to bring things back.
Yeah, that's a tough regime because support is certainly feeling it at that point.
Yeah, exactly. Where you're like, well, we could do this crazy thing, but only if something even worse has happened. It is like kind of a desperation-driven feeling.
Yeah, it's freeing if the site is hard down. You can't make it worse, but at 99% success, you certainly can.
Mm-hmm. Very much so.
I want to come back to the question of transit gateway and how that works. But okay, so after that, what was the fallout of? All right, saw this error, felt kind of powerless. It was clearly a recurring set of issues.
Uh,
What do you do about it?
well, you write an angry email. I mean, I'm kidding, but actually, I think I talked about it with a couple of people that I was in the incident with, and we were all just like, oh, this is like, we don't really like feel very good about this. And so I just ended up like writing a document about it called, I think, like, we should be able to drain an AZ. And I just kind of circulated it around. And I was like, look, it was basically like, we just had this incident. We're doing some incident analysis. We believe that if we had this sort of technology, if we could drain availability zone, which we've always sort of told ourselves that we could do if we really had to do it. I was like, if we really had that, then we could have just done it. Right? And so it was kind of a skeletal outline, I think, about how we might reasonably do this for most services, and about what some of the benefits would be. There was this kind of perception, I think, also originally, that draining a service or draining an availability zone would be something that, like, we would kind of only do in like very, very dire circumstances. Like it would be like doing something very heroic to save the site. And I was like, well, actually, we can make this kind of a more commonplace event, right? Like, the safe way to do this is make this a behavior that can happen, that does happen in the system all the time, and does not require us all, like, kind of existing in this state of panic in an incident channel. Because we should be very confident in it. And once we do that, we get a lot of it becomes a more natural part of workflows, like deploying and troubleshooting. You can get into this place where, like, well, something is bad in one availability zone, so let's like drain all the traffic out of it, and then like we fixed whatever it is, and then put like 1% of traffic back, something like that. If that doesn't work, drain it all out again, put 1% of traffic back. And so you can, instead of like these, I felt there was an opportunity for us to stop operating this kind of like binary event mode where either things were like good and everything was operating, but we couldn't really do anything, or everything is bad, but we can also do everything because everything is down. Yeah, this is kind of like there's an opportunity to like explore some space in the middle, I think, all in the name.
Yeah, that makes sense.
Yeah, right. Yeah.
To what extent was this informed by, you were at Google before this, and Google famously has a gazillion data centers all over the world, and that when I've talked with engineers there, that they think about draining their services as like part of their job. To what extent were you informed by that experience, and were there certain parts of that experience that you were trying to carry over, or certain parts that you were trying not to carry over?
Mm-hmm. Yeah, very much so. Google is definitely the first place where I encountered this idea that one could sort of drain a data center. And the team I was on at Google, the traffic team, among other things, ran the load balancing infrastructure that enabled this kind of draining. I think one notable difference between the way that this was sort of done at Google and the way that we chose to do it at Slack it was informed by kind of the size of the company and the complexity of the services. So at Google, you're a service owner. You probably have pretty much complete autonomy over where you deploy your service, as long as you're like meeting your SLAs. Google has many data centers, and you don't necessarily know where all your backend services are. There's like a high level of decoupling, right? So under the covers, there's hundreds and thousands of services running in Google. And so under the covers, you are a service operator. People underneath or above you are kind of like draining from around you all the time. And that kind of like service by service drain is more common than actually like shutting down a whole data center, which is actually is something that they can be a little more, there's a large cost dimension to draining an actual whole data center. So they tend to be a little more judicious about draining a whole data center. In contrast, at Slack, we were a large service, but we were not, like many data centers large. And we were also 1 to 2 orders of magnitude fewer services. So there's a lot more opportunity. Whereas at Google, they have, like a million user-facing services, Gmail, search, ads, whatever. We really just had Slack. Like, we had auxiliary parts of Slack, but mostly we cared about the service as a whole. And most components were shared across the whole service. So when we did the program at Slack, we made it, maybe collective is the right word, but it was a little bit more of a global regime. I think the first thing that we were focused on was not how will we drain sort of individual services, but how will we just really kind of like clear everything out of an availability zone. And then later, I think we went back and started adding in more kind of per service draining.
Mm-hmm. Yeah, but then, the core piece of Slack that everyone sees is, can I send messages and can I hop around my channels? And that's all kind of one big blob of code that's all extremely tightly intertwined, because it has to be. It can't be separate things.
And there's almost everything. There's a reverse proxy, there's an app server, there's a memcache, and there's like some Vitess components. Almost every request that goes through the site is going to touch those things.
Yeah. And it makes sense so you make a global decision and you say, this is how, like, we should be able to drain Slack out of an AZ, not, memcache. That probably wouldn't help.
I mean, sometimes it did, but yes.
Touche.
Yeah. No, sorry, go on.
Cool. So, angry email. A bunch of people read it. I love the simplicity. I remember actually seeing that posted and thinking, like, this makes a ton of sense to me. How did folks respond to it? And, where'd you go from there?
Well, I mean, I think I'm trying to remember how it picked up, and I think maybe you were around for part of this. I'm not sure. I started hearing, I kind of Cellular, everyone I showed it to was like, oh yeah, this is kind of a good idea. Like, this seems good. And I'm not sure I can't exactly remember how we sort of leveraged from that into starting a project, except I think we got permission to like try a little bit and see how it went. I think we got to a place where we could at least start draining traffic sort of from the front end and not worry about the fan out behind it, and just kind of see what happened. See if the load balancing infrastructure does sort of the same thing. See if it works, even if we only remove maybe like 5-10% traffic. Something like that. Like, we all kind of agreed that would be enough. That would be an experiment that was like valuable but not too risky, I think.
Yeah.
Yeah. Go ahead.
What were you trying to learn in that experiment? Because I think this is one of the things that I really like to ask folks in this conversation, because every big migration has this just so story around it of like, and then we did this hugely ambitious thing. And it's like, okay, but there is almost nothing at this moment where, if I look forward, is an obvious, hugely ambitious thing for any given company to do. It's very much retconned into, well, yeah, and then we figured it out. So, like, at the beginning, there's always a lot more ambiguity. And you mentioned this as an experiment. What were you hoping to learn, and where did you think it would go at that point, just by investing a little bit of work?
Yeah. I think what we were trying to learn is, we'd been through this experience with the outage that we talked about earlier. Excuse me. Where we were like, well, we would have drained that AZ if we could have. And so it was kind of like, well, like, can we practice this in peacetime, as it were, right? Like, can we just start doing some of the stuff that we would have done? And we'll see a couple of things, right? Well, we'll see like the sort of main site statistics, latency and error rates, things like that. But then we'll also get an opportunity to see kind of does our machinery for that work, and we'll get to see what is left behind, right? Like, one of the patterns in this project, I think, is that we iterated on these drains every week or so as time went on, and we had, a couple of like lines on the graph that indicated kind of how much bandwidth we were dealing with in the AZ that we were draining, and moreover that they would be split out by service. And so that was a way for us to see like, this is sort of like bandwidth per service is like a kind of proxy for how much action is still happening despite the drain. So
that makes sense.
That was a way of us kind of being nimble at it.
Got it. And that wasn't like a known thing beforehand that, you start to drain away from the front end. You weren't sure how much of the traffic that was going to get?
Well, we knew kind of how much we could take at a time just based on like some math, but we didn't know kind of anything about what would happen once it hit the app servers, because the high degree fan out the many services behind. For example, like for Memcache and the Memcache configuration we had, we were quite sure we wouldn't be able to remove any traffic. We want to see anyway. Yeah.
That makes sense. So how did you actually do this draining? Tell me a little bit about, we talked generally, it's like shifting traffic or whatever, but like, what does it mean to actually do this?
Yeah. Well, I'm pleased that the techniques that we used evolved over time.
I hear that.
So the first time we did, so you remember I told you that we had this we had this load balancing configuration where we had separate verse proxies sort of fronting each availability zone, and they fed traffic only to upstream web servers, web apps in their availability zone. So the first thing that we did is we actually just started going around and causing the reverse proxies to knack health checks. So they just would not get traffic assigned anymore. For each one that we did in that availability zone, it would not get assigned traffic, and the outermost load balancing layer was seeing each reverse proxy as sort of a valid and equal. It wasn't really AZ aware. So you just go from having like kind of 99 total reverse proxies to 98, 97 or whatever. And so like that was the idea about how we would just sort of through causing those at the top of the AZ to fail their health checks, the AZ as an entirety would get proportionally less traffic.
Got it. How well did that work? It sounds fairly simple.
Yeah, it worked decently well. We didn't get like there's a sort of fineness of control that was lacking. It wasn't extremely fast, right? We had to like kind of go around to a bunch of different servers and like run a command. And then you also, there's this thing where like at some point you'll start running afoul of the sanity checks in the load balancing layer itself. For example, Envoy has this idea about panic mode, where if an Envoy, you can configure Envoy so that if it sees like 33% of its backends are bad, it'll be like, whoa, my health information must be bad. The safest thing for me to do is just start kind of spraying traffic across to all the backends regardless of health status, because I've gotten some bad information. So we did run afoul of that once or twice. I think that was probably like the biggest kind of like, which actually, in the environment of these experiments was fine because the underlying infrastructure is actually healthy, but it brought us to a point where like pagers were going off and the system was not acting like we wanted it to.
Mm-hmm. Yeah, it had reverted to healthy because somebody was lying to it. That somebody was you, who's knocking down services or individual load balancers, but maybe not the fight with the computer you wanted to have. Yeah,
we're kind of conflating these signals of like this backend is healthy with this backend should be assigned traffic.
Mm-hmm. Yeah, that makes sense. You want to separate. Did you? Okay, so a couple of imperfections in that, and you mentioned this evolved. What was the evolution of that tooling?
So in the end, what we actually ended up doing was, so we had introduced the XDS layer, which our implementation was called Rotor at Slack. We had introduced that as kind of a read-only store for service discovery information from console. But the other job of that protocol is to serve configuration information dynamically to Envoy processes. And so there is actually a relatively simple way in the Envoy system where you can just say like, well, assign proportionally less traffic to this zone. So we actually embodied everything in the Envoy configuration and then just like pushed signals. I think the drain signal actually got wrote into console at some point and then replicated back into the XDS system. So it was more just like a knob that was like between 0 and 100% of traffic.
Cool. What did that granularity get you? Like, I imagine Slack had enough load balancers in each AZ that it wasn't that bad, but you did mention that like increment was meaningful. How did you see that show up?
Yeah, I think it honestly mostly it was it eliminated a lot of kind of difficult math around maintaining and unmaintained servers. We could get most of the effect that we wanted. We had I'm pretty sure we would have I can't remember exactly how many reverse proxies we would have in each availability zone, but I feel pretty certain it was like of the order of 100. So we went once we implemented the proportional traffic shifting through Envoy, we had like 1% granularity, but before that, I think at worst we probably had like 3%, something like that. It was just a little bit of a messy control interface, and it also relied on stuff like being able to SSH around. In particular, if we were doing this for real, right, we wanted to SSH to every server in the impacted availability zone, which is a lot to ask if maybe your network is totally hosted.
Probably a lot to ask in an availability zone that is presumably having network connectivity issues.
Mm-hmm. That's a much better way of saying what I said.
Interesting. Yeah, and I guess 3% doesn't sound too awful, but the real number was probably something like 2.7%. And knowing that 5 mainted down services times 2.7 is the graph looking right? I certainly wouldn't want to do that math in the middle of an incident.
Yeah. And then at some point you're just gonna like fall into panic routing anyway, and then you'll be in a mess.
Yeah,
then you'll have to
no good there.
Yeah.
Cool. So how did that tooling, was that tooling part of the original experiment, or was this sort of beyond, had you finished that initial experiment and learned what you needed to learn?
Yeah, I think we did the first few of these. I think my recollection is we did a few of these experiments to the point where we felt like we had some things to go and like work on with some of the different services underneath. And we were like, okay, like, and now that we've seen there's like some good work coming out of this, we can kind of step back and do the bit of work in the load balancing layer to make this like a nicer, more continuous process. Kind of justify the investment in tooling by saying like, well, we're going to like now go do some work on these underlying services and then come back and try this again and see if we can get further.
Got it. That makes sense. So, what did you see that proved that it was worthwhile?
Let's see. So we certainly saw that we were able to decrease traffic to the app servers. We were able to decrease traffic, we were able to decrease traffic in the AZ as a whole. We learned some stuff around, so in particular, my recollection is, so I mentioned two of the important backends are Memcache and Vitesse. And we were like, oh, actually, like for Memcache and Vitesse, we don't see very much failover in traffic at all. This is not surprising for Memcache because we knew that we had kind of a single Memcache node for each key. There's no replication in the system. So, but we weren't entirely sure. There was a theory that we could remove a significant amount of traffic from Vitesse by doing this as well, because Vitesse has some affinitization per AZ kind of baked into it. So there's an idea that we would get some kind of passive traffic draining. And we were a little, like, okay, maybe this is enough because Vitesse we knew that in order to manage these drains through the Vitesse system, we would actually have to do work in the Vitesse system because of the consistency model. And so we did actually learn that we wouldn't, I guess conversely, we learned that we wouldn't get enough out of this kind of passive draining to make it so that we didn't have to go back and do the work on the test failover. So we kind of like it was kind of finding that sort of justified investing back there too.
Yeah, that makes sense. You mentioned earlier that, Google has this model of, 100,000 services or whatever, and or thousands of services, and each of them have this own like fine-grained control behind it, but that's not what Slack did. But it sounds like that you actually learned over the course of this process there were a couple of services where you needed to tackle the services directly because they didn't just passively drain out. How did you think about prioritizing those? Because that's no longer just like your team does some work and ta-da, the system is better.
Mm-hmm. Yeah. I think so. What we actually ended up doing more often than not, there were a few, there were a few services that we could just sort of silo them by AZ, right? Like just make it so that like downstreams in one AZ can only reach upstreams in that same AZ, and it would just work. But there weren't actually that many of them, and not that many of the very important services. So we did end up mostly going to each service kind of service by service. And I think we ended up, I think you actually came up with a lot of this. We ended up doing this kind of like Eisenhower matrixy thing where it was sort of like difficulty versus value, right? And so you had like, low difficulty, low value. You had like high difficulty, low value. Well, we don't want to do those, right? We have low difficulty, high value, definitely want to do those. And then like high difficulty, high value. And those are the ones that are like going to be kind of spendy.
I do remember doing that. I don't remember filling anything out myself. I'm just like drawing out the graph and saying like, where do these dots go?
Yeah.
Because it's not obvious.
Yeah. And in practice, I think it was like me and like I basically went around to somebody from each of these services and I was like, well, let's just do a napkin sketch. Let's do like a one pager about what we think the right way to sort of drainify your services and kind of like how much that kind of has to cost. And that was something that I think we could feed that into our engineering planning process. I think both for the project. So at this point, this was kind of shaping up into this bigger cross-functional project, but then it also, we can make sure that like, since each engineering team is keeping their own roadmap for the service and the work that they want to do over the next year or two, we kind of like dovetail all that in there as well so that people don't, I feel like there's a danger in these cross-organizational projects where people feel like all their work that they need to do to just keep their service stable is getting hijacked for something that's like kind of trendy or a flight of fancy or something. And so there's a lot, I found that in the planning process, there are often times where teams would be like, well, we really need to make, you were asking us to handle another axis of complexity for our service, right? Like now, instead of worrying about our global capacity, we have to worry about each AZ's capacity. Like, can we clean this thing up to make this easier to run? Like, can we reduce some complexity elsewhere? And we were able to like make space in that, or for them to do this work that oftentimes had been kind of deprioritized for them for a while.
Interesting. How much, I think this is an interesting kind of tangent to maybe take in infrastructure in particular, of if you own a service and it costs a lot to own that service, the team who owns that service has the best local knowledge about that service. But when you come in with some global system property and say that we should behave this way, is there a way to navigate that?
Mm-hmm. I think that was a lot of the, I think that's a good question, because often there's a lot of kind of, I don't know if I would say like political or cultural friction that comes up in these cross-functional projects where, I guess as I hinted before, right, like teams feel a little put upon and like they do understand their service the best. And it's true. Like they do actually, like everyone, I sort of believe that every service team is already operating in kind of a local maximum, right? Like given the sort of organizational and technical constraints around them, they're almost certainly doing kind of the best they could. We were able to I think, there's a way in which I think we reflected a shift in organizational priorities, which sounds harsh, but in kind of a good way. I think we were able to say, like, well, like some of this other stuff that that you've been told to do, like, is not as important anymore, right? Like we're like, we can, since we've decided this is an important thing, like, let's take some of these other priorities and make those less important, and let's make this kind of like the most, let's also like kind of wind these things that you want to do around fixing technical debt or making your service easier to run, kind of like wind those into our cross-functional project that we're doing.
Yeah, there's an interesting alignment there of, you have your project, but you also, because you've gone through the organizational ringer, understand the organization's priority perhaps better than anyone else, or at least fresher than anyone else, and can help teams go stack their roadmaps with work that hopefully they think is valuable, and also, aligned with the latest and greatest thinking of what the system should do as a whole, which can feel a little political, but is hopefully a valuable exercise.
Yeah. And it was always important for me to kind of be like, well, I'm coming here to like have some information. I have some information. I have like some knowledge about what has worked for other services, but you need to decide what's actually best for you. And if you say, and we'll sort of like grade it together, right? We can like talk about sort of the quality versus difficulty of the solution. We can go back and forth on that. But at the end of the day, I think like everyone really wants to do their own design work.
Yeah, absolutely. That's the hard and thinky part of engineering. I guess 2025. So AI is going to do all the stuff that's not hard and thinky, right?
It's work already.
What were some of the systems that were lived in that like easy and high value area versus like what were the systems that lived in hard and low value? And was there common traits that kind of shoved them in one direction or the other?
Yeah, for sure. We would talk a lot. I think in particular, we started talking a lot about stateful versus stateless services, right? Like services, like the web apps example would be sort of your canonical example of a stateless service, right? Like they're kind of born, they die, they get all the data they need to serve more or less from services upstream to them, right? And so those are almost trivial for us to do because we just kind of like hack them up by AZ, right? Like we just say like, okay, like you have we introduced like a filter in the service discovery layer where you could just get like a magical list of servers that were all in your own AZ. So we just kind of like groomed those into silos, one per AZ, and that was completely trivial. I would say the other, on the other end would be like the Vitesse infrastructure, right? So Vitesse runs in these, in these replica sets, usually about like 5 wide, and all the replica sets have, each member of a replica set has all the same data, but only one of them is primary at a time. And so to accomplish a failover in the Vitesse system, you actually have to send a signal to each replica set that's like, you are not primary anymore. One of the others needs to be primary. And so that actually has to be managed through the Vitesse orchestration framework. So the database team actually had to do a fair amount of implementation work to make this happen reliably and quickly across thousands of replica sets. I think that was probably one of the like higher complexity, but also like higher need, right? Because that's a very important data source, and we do actually not want to be sort of writing data first into an impacted AZ when we're in that system. Yeah, and then in the middle, I think I'm thinking about like memcache, where like the memcache, we started in this place where we were treating memcache as it was a strongly consistent data store because we had one big kind of like global memcache ring for the site. I'm leading some details, but we were each piece of data was basically on one memcache server, and so I believe there we actually You've talked to Glenn already. There's another episode.
Yeah, we talked with Glenn a couple of weeks ago on how some data that everyone needs at the top of the hour is all available on one memcache shard.
Yeah,
that's horrible.
So we had to figure out what to do with that. Yeah, and I recall, it was something where like we basically introduced a bunch of a per AZ replica of each memcache, and then kind of like had to go through the code and figure out where the consistency was important and where it wasn't.
Mm-hmm. Yeah, absolutely, that makes sense. How would you think, for folks who are thinking about this, by default, a lot of systems are probably not designed for how can I split my site up into 3 proto-independent sites 10 years in the future when we're at tens of millions of users. Is there anything that you would encourage people to think about like early on in system design to make this more plausible later? Or is this just a big company problem?
It's certainly tempting to say it's not. I mean, I do think there's a life cycle, I think there's some companies that have to deal with a lot of different sites early on, and they have to think a lot about how their data is kind of flowing back and forth. And so they deal with that kind of naturally. I think it's hard to say when, it's hard for me to say kind of off the top of my head, just when exactly this is a good idea or like something to do. I will say that there's like something organic in it, which is that at some point you'll become aware, if you're assuming you're hosted at AWS, you'll become aware of the cross AZ transfers. And I think in general, it's really useful, even from the beginning, to be able to segment your monitoring by availability zone. And that's a good place to start kind of like getting your feet wet. And then you can at least see, you can look at bandwidth or RPCs and just see what is kind of flowing back and forth. Usually, I think usually the first step is like getting some observability and some measurement in the system.
Yeah, that makes a lot of sense. Like you need to be able to see it. You need to know if this is a problem for you. And that pairs really nicely with, as you said earlier, the cost thing tends to be a leading indicator of how much you should care about independent AZs. Everyone's going to hit some amount of cost if you're not aggressively thinking about it.
Yeah. And I think another thing to think about that people often don't is that there are a lot of the time, if there's one logical instance of something, then that is kind of somehow or another a single point of failure. I'm thinking, particularly like if you have one transit gateway and it sits in between all of your availability zones, it is unlikely that the physical component will fail in all these availability zones, but it's very likely that somebody will eventually misconfigure it through the console.
Mm-hmm. Yeah.
Yeah. And so this will kind of like have the same effect. And so I think there's, like when people sort of like fat finger things, as we say, there's often, I feel like, a lot of emphasis on like not making the mistake again and like linting or like doing the right code review or whatever. But I think it's also a signal that there's a good opportunity to maybe increase some redundancy here.
Yeah. I remember one of the things that blew my mind was talking to some large customer of Slack's, and they pointed out that they consider Slack a single point of failure because it's just one thing. It's like, of course, looking at it from the inside, like I promise it's many things, but from a first, a good product presents as a single unified thing, and you don't want to have to think about it. Of course, if you want redundancy, their thought was like, do we need to go buy a second chat solution that everyone sits in? And my purpose in that meeting was to talk them out of that. And I think we mostly did, because it's a horrible question, but this is true at every layer in the stack, right? The product, the load balancers, the internal services, like everything about it. A single point of failure is a single point of failure, and those don't feel good.
Mm-hmm. Yeah. And also I will say, like, based on my experience, it is much more likely that outages will be caused by a human misconfiguring something than by some underlying equipment failure.
Absolutely.
Yeah. And so that's actually, like, I feel like that was one of the places in this project where we were able to accomplish the biggest shift in thinking, when we were like, oh, this is not just a tool for a data center caught on fire, but this is also a tool for somebody just misconfigured some software, a bad deploy went out.
Yeah. And if you can drain away from it, that's substantially different.
Mm.
So, where did things end up? What was sort of the final state of the system when you left?
So the final state of the system when I left was that we could drain. I couldn't tell you exactly what the numbers were, but we could drain all the critical services out of an availability zone. And I think our goal was like 5 minutes or less. Most services would drain a lot faster. The
Dang.
5 minutes or less was mostly, was driven by, I think, like some of the underlying database work. We got to a place where we were doing it every week. So our kind of, we didn't talk about this that much, but as we iterated on it, the cycle we used was to kind of like get everybody together on Friday mornings who was like involved in the service and be like, okay, we're going to drain the site together. And everybody, like rides along in the incident channel until you get enough confidence that like your service won't go down under drain, and then you don't have to pay so much attention anymore. So we kind of like rode along with that until we felt that we could really address most of the significant traffic, but we were also kind of okay leaving a long tail of stuff to be cleaned up. I'm thinking particularly about like the memcache migration work, where we knew that there were a bunch of keys that would need to be migrated over time, but we had a lot of confidence in the basic approach of things. And I do, this is something I talked about in the QCon talk, but not so much here. Is that I think like one of the keys to success here was that we were able to find something that was incremental and did not require every service to kind of like walk along the program in lockstep. So we had this kind of, I think we got to this place where things we felt were like mostly done, but there were some important work streams that would keep on going for maybe as long as a year.
Mm-hmm. Yeah, that's I think hugely powerful. That a migration where 90% done is 0% value sucks.
Mm-hmm.
It feels bad, and some of them are just have to be that way. That if you are slightly out of compliance, you are out of compliance, and that triggers a whole bunch of things. But if the goal is performance and reliability, you can be 80% done, and that is just 80% done.
Mm-hmm. Yeah, and it's also fragile, to be delivering value so late in the project, because you haven't, until you've like, I feel like you're kind of at risk until you're delivering real value and you have things kind of locked in.
Yeah.
At least
absolutely.
It strikes me the other thing that was important by the sort of formal end of the project was that we had gotten sort of the system defaults for things to be in this kind of new AZ-ified world. It was in a place where like if you're setting up some new infrastructure, there are different guardrails in the system that would sort of discourage you from doing things in a global way by default. You'd have to kind of like, like sign, like I promise that I solemnly swear I'm up to no good before you could like what problem.
And incurring cross AZ traffic bills. I think part of the original quote. That's cool. That makes sense. And it really like locks in the progress going forward. So you don't end up with, you having to shepherd this process literally forever in order to make it valuable.
At some point, like you need to, the organization needs to kind of like pick up the load.
Absolutely. We're about out of time, so I'll ask one last maybe spicy question. Would you recommend people use console? And if so, how? If they're just starting a project?
Deeply loaded question. I mean, I think it's, what can I say? How can I say it? In short, probably not. I think that, as I mentioned, there's this sort of like attractive nuisance quality to console, where on the one hand, it's like a pretty easy to use service registration and discovery system. And on the other hand, it's a lock server. And like these things are just really, you need really different guarantees from each one. And those should probably just be separate systems. Like it's okay. Like we have, you can use the AWS native service registration or just kind of whatever else. But like for service registration discovery, you need an eventually consistent system that is going to guarantee you high uptime. For lock service, you need well, you need strong consistency, right? It's just necessarily going to be a more delicate system from a reliability perspective. And so you should probably just, I think that the needs of these things are sufficiently divergent that they should just be two systems.
That makes a ton of sense. Cool. Well, we are just about out of time. Thank you so much for coming on the show. Is there, I guess, the one standard wrap up question? Where can people find you on the internet if they want to learn more about this or get in touch with you?
Yeah, I'm mostly present professionally on LinkedIn. My name's Bethea. I'm pretty inactive on other social media right now. If you look at my LinkedIn profile, there's a link to the talk I gave at QCon last November where I expand on this in a lot more depth.
We'll make sure to drop a link to that in the description.
Thanks so much for having me, TR. I've enjoyed this.
Thanks so much for coming on.